the consumer's problem, or our theory of the consumer's problem, is the classic problem in decision theory. So we spend a lot of time on it, but the principles that we get from it are applicable for many other different kinds of decision problems. So this is the problem of the consumer is also what underlies the demand function. So we're going to use this to derive the demand function. We won't get to the demand function this week. Unfortunately, it's going to take us too long to get there, but we'll get to it next week, I promise you. So you just have to be patient. We're going to talk about a single consumer, first of all, and then next week we're going to put all the consumers together into a market after we have each of their individual demand functions, and we're going to derive the market demand as the sum of all consumers' behavior. And we're going to, however, now, as I said, consider just a single consumer, and we're also going to consider single goods. There are all different kinds of goods that we could consider. We're going to use the example of food and clothing, a consumer's choice of how much food and how much clothing to purchase, but those could be other things too. They could be furniture, they could be health care, they could be vacations or haircuts. They could be, in other kinds of analysis, children. So we can think about choices of children have been cast in as a consumer choice problem. They're certainly used for deciding for decisions about work. So whether or not to work for pay, how much to work. So for labor problems, and for criminal behavior too. And we'll be looking at some of those applications, but not all of them. So the theory of the consumer is really a theory of how the consumer responds to incentives. Okay, and the way we're going to understand the consumer's behavior is in 3 steps. And these are the same 3 steps that we use in any kind of decision theoretic model, any kind of economic model of decision making. So the 3 steps are, first of all, the consumer has goals, has objectives. In the case of the consumer, we call these preferences. The consumer has preferences. So we're going to want to understand, well, where do these preferences come from? How can we analyze them? Secondly, there are constraints. So we talked about these last time as contingency. So this is the external environment that prevents the consumer from getting everything that he or she wants. And in the case of the consumer, we call the constraint the budget. So a fixed amount of money that can be spent on consuming different goods. And then the third step are the choices that the consumer makes, and that is going to lead us to the consumer's demand for different goods. So this is a positive theory of consumer behavior. Positive in the sense that it's trying to describe the behavior and predict behavior changes in response to changes in the environment, changes in constraints. But at the same time, while it's a positive theory, There is also arguably a normative component in the sense that maybe this is how people should behave, especially when they have very important decisions to make. This is the slow thinking that Daniel Kahneman talks in the book that we mentioned in the last class, Thinking Slow and Fast. Okay, so we're going to analyze this consumer's preferences, so that's what we're starting with here. Consumer preferences in as simple as possible a way, assuming that there are only two goods that are possible to consume. And we're going to label those goods as food and clothing. Okay? These can stand for any two goods that you like. One of them can be avocados, if you prefer. The other can be salsa. You know, any two goods, or chips, and I don't know, something else. So, and we're going to talk about market baskets. So a market basket is a combination of an amount of food and clothing, and we're going to denote a market basket as the amount of food and the amount of clothing. And that means that we can graph a basket where the horizontal axis represents the amount of food, the vertical axis represents the amount of clothing, and every point in this upper right quadrant on this graph is a basket. I say upper right quadrant because the other quadrants don't make sense here, right? If we talked about the lower right quadrant, that would imply negative clothing, which would be, well, we don't consume negative clothing, and if we talk about to the left of the origin, it would imply negative food. So we also don't have anyone consuming negative food. So what's relevant is this upper right quadrant, and we have different baskets in that quadrant. So for instance, if we label this basket as A, so is X, so X here would have coordinates F1, C1, and we have a second basket, Y, which has coordinates F2, C2. Question we would like to address is, which does the consumer prefer, X or Y? Any ideas? Cannot be determined with information given, right? So we don't know yet, but we would like to make progress in understanding a choice like that. It's not obvious. So we're going to be in discussing preferences. We're going to be discussing comparisons that consumers make across different baskets of goods. They're not comparing the goods themselves generally, so they're not saying, oh, I like food better than clothing, right? That's kind of a ridiculous statement. Or I like clothing better than food. I don't know, somebody might say that, but actually, you know, you gotta have some of both, basically, right? So, you know, this is not about whether you like pizza better than pasta or beer better than wine. This is about comparing situations where probably you have some of both of the goods, and we want to know what it is the consumer prefers. And So notice, so sometimes people say, well, what we need to do is we need to add C1 plus F1 and compare that. C, is it greater than C2 plus F2? Does that make any sense? That's like saying, you know, 3 pairs of jeans plus 2 loaves of bread. Right? You can't add, these are things that cannot be added. They're incommensurate. So that's not going to help us to figure out, you know, add up the total number of units of clothing and food for each of them. That's not going to answer the question of what the consumer prefers. Instead, we need to have some apparatus. We need to have a theory of the consumer's behavior. As we said last time, a theory starts with assumptions. So far, we just had, these are definitions, right? They're not really assumptions, they're just definitions. Now we're going to make assumptions about consumers' preferences. The first assumption is called completeness. This means that this consumer of ours can compare any 2 market baskets that you give him or her to compare. For any X and Y in this space, any 2 market baskets, the consumer can say either X is preferred to Y, so I like X better than Y, or Y is preferred to X, or X and Y are indifferent. So given 2 baskets, the consumer is always able to state which they prefer, or if they don't care. So this consumer doesn't have the problem, you know, we probably all have. You go out for lunch and you look at the menu and, you know, I can't decide, sandwich, salad, soup, oh, I can't make up my mind. This consumer has no problem making up his or her mind. And for any 2 baskets, you know, you could ask hypothetically this consumer, which do you prefer? This consumer always has an answer. Consumer knows his or her. Is that okay with you? Yeah? Second assumption, non-satiation. What does that mean, satiation?
To be satisfied, to be filled.
Clay?
Satiated, to be filled or to be satisfied.
Yeah, so this consumer is never full, right? Never has enough food and clothing. Can always enjoy some more, right? So sometimes this is called more is better. What do you think about that? Just like we all sometimes have problems choosing what to have for lunch, you know, sometimes we actually do get full, right? But this consumer doesn't get full. Why? Because we want to focus on meaningful economic problems where there is scarcity. So you can think, well, so this is a situation, you know, this is relevant for situations of poverty, of hunger, or for middle-class families that, you know, just could use some more resources. This is maybe less relevant for certain billionaires, although they tell me that, you know, you're never satisfied, but that's kind of hard to believe from my perspective. Anyway, for us to have interesting questions about resource allocation, it needs to be the case that more is better. So in a way, we kind of have to make that assumption. So is that one okay with you also? You guys are pretty easy so far. Let's see, the third one is transitivity. transitivity is a kind of a consistency of preferences. Basically, it means, so if X is preferred to Y, so the consumer will choose X over Y, given that choice, and Y is preferred to some other bundle basket Z, then, so if these are both true, then it must be the case that X is preferred to Z. Just kind of consistent behavior. Is that okay with you also? Well, in case it's not, we can make a kind of an evolutionary argument for why this might characterize people's preferences. Like, suppose that these are bottles of beer. So we have 3 different kinds of beer. Let's say we have X equals, I don't know, tell me some kinds of beer you like. Heineken. And Y?
Lagunitas.
What was that?
Lagunitas.
How do you spell that?
Lagun.
Hmm?
Yeah, like that.
Lagunitas.
Baudelaire or something?
Yep.
That's fair.
Is that right? I think I might have drunk one of those actually. And Z?
PBR.
BBO. Okay. So, now suppose you have a friend, you know somebody, you meet somebody in a bar, okay, it happens, and they have non-transitive preferences. Okay, so suppose their preferences are, so X is preferred to Y, so they prefer Heineken to Baudelaire, and they prefer, let's see, we're gonna write 3 things here. They prefer Baudelaire to PBR, and however they prefer PBR to Heineken. I switched my notation here. Y is preferred to Z, and Z is preferred to X, right?
Wouldn't X be preferred to Z?
Well, this is someone with non-transitive, right? So sometimes when we're trying to understand some principle, it helps to assume the opposite of it and see what happens. Okay, so you meet this person, and let's say, you know, this is you and this is your friend. He may not be a friend at the end of this, as you'll see. So initially, just let's say you start with X beer and your friend starts with a Y and a Z. Okay, so you say, okay, old buddy, old pal, you know, we know that you prefer an X to a Y. So let's trade my X for your Y, and because you prefer the X to the Y, you can give me a little money, you know, just kind of make it even, right? So if they really prefer that, so then you make the trade, so you have the Y, and they have the X and the Z, plus you have some money, okay? And then you say, you know, a little while later, hey, you know, we know that you prefer a Y to a Z. So let's trade my Y for your Z, plus because we know you like the Y better than Z, you give me a little bit of money. Okay, we'll make the trade, so now you have the Z and you have more money and your friend has, let's see. XY, thank you. As XY. A little while later you say, well, we know you prefer Z to X. So how about I trade my Z for your X?
So it's just unending.
And, you know, you give me a little money. 2, of course, right? Because that's only fair since we know you prefer the z to the x. Okay, so you make this trade with x plus $, and your friend has y, z. So basically you're back to where you started, except you have some money from your friend. This is called a money pump. You just, keep cycling through this until you've taken all this person's money. So the idea is non-transitive preferences cannot survive in any world with con men. We're just going to get everything taken from them. Okay, so we all need to have consistent preferences if we don't want to get ripped off. Okay, the fourth assumption is called convexity. Anybody know what that word convex means? It's a mathematical shape, right? And we're gonna get precise about that a little bit later. But here, for the moment, what we're saying about this consumer is that this consumer prefers to avoid extremes. So, in the context of food and clothing, this consumer prefers, somewhere in the middle of this to having like a huge amount of clothing. It's all coming out of the closets and dressers because there's no room for it all, but nothing in the refrigerator, right? Doesn't like that. Also doesn't like having the refrigerator overflowing, but no clothes to change into. So the consumer prefers mixtures or variety. Mixtures of variety are preferred to extremes. Okay, so I think food and clothing are actually good examples of that. There might be other things that are less good, but for many problems, this is a plausible assumption, and we're gonna develop it more. Is this one clear? Any objections to it? And the fifth assumption is exogeneity. So preferences are exogenous. What does that mean, exogenous?
Ever changing?
They're what?
If they can change at any moment?
That's actually a good way to think about it. They don't change. So the thing is, they can change, but the way they change is it's self-exogenous. So they come from outside. We're taking them as given, right? Consumers have tastes, and we're not really inquiring as to how they get their tastes. Maybe it's genetic, maybe it's early education or their family or something like that. Different people have different kinds of preferences, and we're just taking that as a given. That leaves out some really interesting cases and types of goods. There are certain kinds of goods that you learn to like or possibly dislike. You remember your first experiences with alcohol, right? First time you tasted alcoholic beverages, wine, it didn't taste so good, but after repeated exposure, your tastes may have, I don't know individually, but they may have evolved so you learn to enjoy drinking wine. Or that could be true of other things too. Spicy food, we stick with food. Certain kinds of music, opera. So first time people listen to opera, what's that screechy singing? It's the soprano, it's too high, right? But you listen to it for a while, maybe your ears get numb, but actually, you can start to really enjoy it and love it. Actually, speaking of love is, preferences. These are endogenous, so you interact with someone, and exogeneity is kind of like love at first sight. There's no important interaction. But with endogenous preferences, then it's the process of getting to know someone that leads to falling in love. So we're going to be assuming exogenous preferences because it makes things a lot simpler, while recognizing that there are interesting cases we won't be covering of those kinds of goods that you can learn to enjoy by repeated exposure to them. Okay, so those are actually all the assumptions that we're going to need. From here to the demand curve, we're not really making any other big assumptions. We're going to define some things along the way, but there are no crucial assumptions. So that's kind of remarkable. Well, here's another definition. Let's define something that's going to be very useful, which is an indifference curve. An indifference curve is the set of baskets, so the set of points in this quadrant among which the consumer is indifferent. Okay, so there are going to be some points like that, and we can find them, we know, because of completeness. But let's think about what the shape of the indifference curve would be. So if we were to draw a graph here, let's see, I'm putting food on the horizontal axis. Let me be consistent about that. It doesn't really matter, but just for consistency's sake. So let me ask you this question. Suppose we take 2 points, let's call them X and Y, 2 baskets. Let me ask you this. Can those 2 baskets be on the same indifference curve? Is that possible? Why not? Eric?
It violates insatiability because X has fewer goods total than Y.
What do you mean fewer goods total?
So if you're looking at units of clothes and units of food, and these are the 2 goods that you're looking at, and the consumer is going to be spending their entire income on those 2 goods, then they would prefer basket Y because they're receiving more of the goods.
Okay, so far we don't have any income here, so this is just about preferences. And so we don't want, once again, to do that comparison. Remember, I erased it here where I wrote F1 plus C1 and compared that to F2 plus C2. So I think you're on the right track, but it's not the total amount. So how does Y differ from X? Chris, you had your hand up.
Yeah, it looks like it's Y is both goods have increased by the same amount or by a proportional amount in regards to X.
Okay, so that's not crucial. Remember how we measure clothing, how we measure food. You know, these are 2 completely different goods. We can't compare them. The same question I would ask if I had done this. Okay? So Y, compare for Y how much clothing there is relative to X. Is there more or less?
More is better.
So, yeah, but there's more
Right.
clothing at Y than X, right? What about food? There's more food also at Y compared to X. So the important thing for Y versus X is that Y has more of each good, of both goods, somehow not of the 2 together. So that might seem like a, you were trying to say that. I just want to be careful that, so it cannot be the case, given these assumptions, that X and Y are on the same indifference curve. And the assumption that would be violated in that case is the assumption of non-satiation. So if consumers not going to be satiated, then these cannot be on the same indifference curve. So essentially, we have just proven that an indifference curve cannot be upward sloping. Instead, it must be downward sloping. Okay, so let's talk more about the shape of the indifference curve. Another point is, well, so we can talk about an indifference map. So the indifference map is the set of all of the downward sloping indifference curves that cover every point in the quadrant. Okay, so that would be a description of the consumer's preferences. But let me ask you this, is it possible for us to have two downward sloping indifference curves that intersect? Like that.
Yes.
It is possible? Okay, well then, let's compare. So call this X, call this Y, and call this Z. Three different baskets. Tell me about X versus Y. Which is preferred? X has to be preferred because it has more of both goods, right? So we know X is preferred to Y. What about X versus Z? They're indifferent. And what about Z versus Y? Indifferent, right? Because they're on the same indifference curve. So, but by transitivity, if X is indifferent to Z and Z is indifferent to Y, it must be the case that X is indifferent to Y. So X cannot be preferred to Y. So indifference curves, therefore, cannot intersect. Could they intersect in a, so the way I drew them is they're crossing. Another way to, so suppose one looks like that and one looks like that. Is that possible? Also not possible, right? We can just make the same argument. Take a basket here and a basket here, compare it to that one. So indifference curves cannot touch each other. If we look at two different indifference curves that somebody has, and we compare this X with this Y, which looks a little bit like these 2 points here, which one is preferred? So between X and Y, which basket is preferred? They're indifferent? Well, X and Y are not on the same indifference curves, right? X is on one indifference curve, and Y is on another indifference curve. They're two different indifference curves, they're not touching each other, they're not intersecting. But on the basis of this graph, can you tell me if X is preferred to Y? Or Y is preferred to X? Yes, you can.
Is X preferred to Y?
Yes, X is preferred to Y. How do you know that, Clay?
Because it's a larger dimension. It's a larger slope.
A larger slope?
So I
Well, the
guess that-
slope could be
So relative-
exactly the same.
Relative to Y, there are more goods available on either end of the curve.
Well, no, so X is characterized by less food than Y, right? X has less food than Y. It has more clothing but less food. It's just like we had here, right? So, but now I've drawn indifference curves through them, so now you have more information. But it's not that, X does not have more of both goods. Hayden?
Is it because the indifference curve for where X is to the right of the other indifference curve?
Yeah, so how could you, that's correct. And how could you develop that argument? Quincy?
The net value of your basket is going to be greater on the X.
The what?
The net value of your basket.
We don't have any value here. We just have amounts of food and clothing. One of them for X, we have F1 and C1, and for Y, we have F2 and C2. There's no money here, there's no income. We're just asking a consumer to compare this basket X and this basket Y.
With the
But
average
now we have the
quantity.
additional information that the X basket lies on an indifference curve, which is up and to the right of the indifference curve that goes through Y. Hayden?
Is it because any point on the rightmost one is going to be, there's going to be a greater quantity of either good?
Of either good?
Or both goods. At any point on the rightmost indifference curve is going to satisfy the non-satiation.
Well, any point on this indifference curve,
Because total is going to be more than.
Would you say?
what do you mean total? So that's why
Average
we don't wanna
quantity.
add F1 plus C1, right? That's what we don't want to do. That doesn't make any sense. We can't add, I don't know, what did I say, loaves of bread. We can't add avocados with sweaters.
So you can't average.
You know, this is a meaningless concept. When we talk about spending money on them, which we'll get to a little bit later, you know, then we can talk about the amount of spending, but we can't add up the quantities of the two different goods. Din?
When I brought vertical X, so from the matrix X, you brought a vertical line, so it cut the indifferent curve of E.
To here?
Yeah, X5. Yes.
Like this?
So because they are in the same indifferent curve, so that's it has the same satisfaction. But because it's a lower than X, because X has more growth than
Uh-huh.
X5. So
So you're saying that if we think about this point here,
yeah, sure.
let's call this point Z,
Yeah.
okay? So this is point Z. Think about point X versus point Z. What has to be true?
X prefers Z.
X has to be preferred to Z because X has the same amount of food, but it has more clothing. And so on non-satiation, it must be the case that X is preferred to Z. What about Z and Y?
Indifferent.
They are indifferent because they're on the same indifference curve. So those two things together imply that X is preferred to Y. Okay, so if we see somebody's indifference map, if we can estimate what it is, and economists actually do this using data, then we can predict their choices even for what appeared to be essentially non-comparable, right? At this point, we had no way of comparing them. Now we can compare them. So indifference curves that are up and to the right have to be better, all the baskets on that indifference curve, compared with an indifference curve which is down and to the left. And we know these indifference curves are distinct because they cannot intersect. Right, so downward sloping, non-intersecting or even touching, and prefer baskets on indifference curves to the up to the right. Okay, so I'm making a lot of use of this graph here. Here, why don't I instead move over here? So there's another property of indifference curves, and that relates to the slope. Okay, so I'm just going to assert to you for the moment that indifference curves tend to have a slope which looks like this. Let's see, clothing and food. Anybody know what this shape is called? Mathematics? That is a convex shape. So convex means in mathematical terms that the slope is increasing. So an indifference curve is downward sloping, so it has a negative slope, but you can see as we move along it, the slope is increasing. It's moving towards positive. In calculus terms, the first derivative is negative, and the second derivative is positive. You don't have to know that part of the definition, but this shape with an increasing slope is convex. I think that's an important thing to know. And so the increasing slope, well, we can characterize the slope in terms of the marginal rate of substitution. So the marginal rate of substitution is going to equal the negative of the slope. Why do we do it as the negative of the slope? Well, because the slope is negative and it's just easier to convert things into positives. And so as we move along the indifference curve, we have a diminishing marginal rate of substitution. So convexity here means the same thing, is equal to a diminishing marginal rate of substitution. Now, so what does that mean for this consumer? Well, so we're moving along an indifference curve, and so it means, therefore, that all the baskets on the indifference curve are indifferent to each other. And so let's compare. Suppose we start at a basket like this, where the consumer has not very much food, but a lot of clothing. And we say, well, to get a little more food, say to go from here to here, how much clothing is this consumer willing to give up and remain indifferent? The answer to that is the slope of the indifference curve. Here, where we're starting, that amount would be equal to this. This would be the change in clothing associated with that same change in food. If we compare that to a point out here where the consumer has a lot of food and not very much clothing, and we ask that same question, well, to get that same change in food, how much clothing would the consumer be willing to get up? What would be willing to give up? The change in clothing would be much smaller. So this marginal rate of substitution is measuring exactly that. So at the up and to the left on the indifference curve, because the consumer doesn't have very much food, but he or she has a lot of clothing, relatively speaking, he or she's willing to give up a lot of clothing to get an additional unit of food, a certain amount of food. But when he or she already has a lot of food and not very much clothing, he or she is not willing to give up much food, not much clothing to get that same additional amount of food. So that's the intuition for convexity, for the diminishing marginal rate of substitution. So we can have special cases, extreme cases of indifference curves, and you can think of these as limiting cases, cases that may not exist in reality. So if we have indifference curves, for example, that are linear, that have a constant slope, so these would not be convex. This would be for two goods that are perfect substitutes. So essentially, you know, you're indifferent between
Milk and butter.
between what?
Well, milk and butter was used as a substitute in the homework.
Milk and butter.
No, I'm sorry, they were complementary goods.
It depends on what you're cooking.
butter and margarine.
And then if you're making a white sauce, so you start by warming up the butter, and then you add some flour, and then you're going to add milk, you know, to make a gravy. So they'd be complements then, right? Perfect substitutes. It's even hard to think of things that are really perfect substitutes. I think the book uses actually an example of two kinds of juice. You know, a glass of orange juice, a glass of grapefruit juice. Actually, most people I know don't think of those as perfect substitutes. But anyway, so these are things where, you know, actually the the convexity, the mixture, the willingness to trade doesn't vary along the indifference curve. And the other extreme would be indifference curves that have this kind of shape. This is actually easier to imagine, although not for food and clothing. These would be perfect complements. These are things that always go together. They go together so much so that, in the sense that so if this is the indifference curve, suppose you're at this point here where you have, say, one of each of these, one unit of F and one unit of C. Well, having an additional unit of F doesn't make you any better off, because without also having more C, you're still on the same indifference curve. So a good example of this would be, you know, right shoes and left shoes, right? So usually you need both of them. Or, I don't know, it's been argued by some of my students that pizza and beer are perfect complements. One slice, one glass. Anything else? Wine and cheese. Probably not perfect complements, but anyway. So this would be an extreme case. Again, this is not strictly convex. So more realistically, we have goods which have relatively straight indifference curves. These are goods that are substitutes. And we have goods with relatively curved indifference curves, and these would be so different pairs of goods are going to have different looking indifference curves, and different individual consumers are going to have different shapes of indifference curves. Okay, and we can also think systematically that different kinds of people may have different shapes of indifference curves. So let me give you a nice example that I liked from your textbook of where we're considering not actually two different goods, but two different attributes of a particular good. So the example is, cars have, say, two characteristics. They have speed and they have space. Symmetry. Some people, tend to view the trade-off between space and speed differently from other people. And in your textbook, so two different demographic groups are distinguished. One of them is young single people, and the other is people with families. And say we're putting speed here and space there. Then what would their indifference curves look like? How about you think about that, and we'll take a short break. When we come back, maybe you'll have some answers for me. Okay?